Hi everyone, a very good evening to all. Now we are going to study about the various thermodynamic process. To understand the thermodynamic process, first thing what we have to understand is heat. So heat is a form of energy, and here we need to understand about the formula for delta Q, that is ms delta theta, or delta Q equal to m nc delta theta. So first one is for M mass. Generally we use for solids and liquids, or you can also use for gas, but very less times we use. And S means specific heat. Here N means number of mole, C means molar heat capacity, and at constant pressure it will become NCP delta theta, and at constant volume it will become NCV delta theta, where Cp minus Cv equal to R and Cp by Cv equal to gamma adiabatic constant, and we need to remember these formulas. And when you consider internal energy of any gas, that is given by U equal to F by 2 nRT, implies delta U equal to F by 2 nR delta T, and for any process it is also equal to NCV delta T. So that Cv equal to Fr by 2 implies Cp equal to Cv plus R. So equal to Fr by 2 plus R. Fr by 2 if you take common, 1 plus 2 by F implies Cp by Cv equal to gamma equal to 1 plus 2 by F, where F is degree of freedom, and degree of freedom, see F is degree of freedom, where for mono F is 3, for di F is 5, for triatomic F is 6. And comes work. When you consider work equal to P delta V if pressure is constant, and work equal to integration P dV from V1 to V2 when pressure is variable. And work is also equal to area below P versus V graph. And for cyclic process, for any cyclic process, work equal to area of cycle. And here one thing you have to remember, that clockwise means positive work done. Anti-clockwise cycle means work done is negative. So these are the things you need to remember about the heat, internal energy and work. And you also have to remember the sign convention, like heat given or heat absorbed by the system is positive. Heat rejected or released or extracted from the system is negative. And increase in internal energy positive, decrease in internal energy negative. Work done by the system is positive, work done on the system is negative. Generally, work done by the system means expansion, work done on the system means compression. So these all things you need to remember. Now when you consider what are all the various thermodynamical processes, the very first thing when you consider, that is isothermal process. When you consider isothermal process, the condition is temperature constant and the equation is PV equal to constant. So that P1 V1 equal to P2 V2 and the work done will become 2.303 nRT log V2 by V1 base 10. Or P1 V1 equal to P2 V2. So V2 by V1 you can also replace with P1 by P2. And the next one is isobaric process. Isobaric process means pressure is constant. As pressure is constant, V by T equal to constant and work done equal to P delta V or else NR delta T. Now comes isochoric process. Isochoric process means volume is constant Volume is constant means P by T equal to constant. So that here work done is 0 because delta V is 0. And adiabatic process. When you consider adiabatic process, here delta Q equal to 0 and the equation is PV power gamma or TV power gamma minus 1 or P power 1 minus gamma T power gamma equal to constant. And here work done equal to P2 V2 minus P1 V1 by 1 minus gamma. Or else it is also can be written as NR T2 minus T1 by 1 minus gamma, nothing but NR delta T by 1 minus gamma. This is what adiabatic process. Now, for every process, delta U always you have to consider that NCV delta T. Now, in case of isobaric, when you consider, see delta Q equal to NCP delta T and delta U equal to NCV delta T and delta W equal to NR delta T. So if you substitute from this, you can get the relation that Cp minus Cv equal to R. Because here there is a law, that first law of thermodynamics. What is first law of thermodynamics is, in every process delta Q equal to delta U plus delta W with proper sign convention. So that the above equation, if you substitute delta Q, delta U, delta W, then you will get Cp minus Cv equal to R. Now, this first law of thermodynamics you can apply to every process. Like for isothermal process, when you consider, isothermal process means delta T equal to 0. So that here delta U will become 0. So delta Q equal to delta W. And isobaric process, when you consider, delta Q equal to delta U plus delta W. So that Cp equal to Cv plus R. Or else for isobaric process, when you consider delta Q by delta U, when you consider Cp by Cv, it will become gamma. Or delta W by delta Q, when you consider, that is nothing but delta Q minus delta U by delta Q, that is 1 minus delta U by delta Q, nothing but 1 minus 1 by gamma. Fraction of heat energy utilized in doing work. And isochoric process means, so V0 implies delta W0 implies delta Q equal to delta U. That is nothing but NCV delta T for both of them. And for adiabatic process, when you consider delta Q is 0 implies delta W equal to minus delta U or delta U equal to minus delta W. And you can represent the same thing as a PV graph also. Like when you consider PV graph, P versus V. Now, like this. This is isobaric and this is isochoric and this is isothermal and these three are adiabatic and here this is mono, this is di, this is triatomic. And if you consider compression, like this it will come. So now this is isothermal and these three are adiabatic and this is mono, this is di and this is tri and this is isochoric. And the first graph is in case of expansion because volume is increasing and the second one is in case of compression. And here you need to remember that slope of PV graph for isothermal process is minus P by V. Slope of adiabatic process for PV graph is minus gamma P by V. So slope of adiabatic is more. That's why here these three are having the more slope. That's why we represented as adiabatic. And here upper three are having more slope. That's why we considered as adiabatic process. So that is the way you can analyze all the thermodynamical process using the graphs also. Now comes the example questions. Let's see. The very first question is the amount of work done by 0.2 moles. Number of moles is 0.2. At temperature 27 means 27 plus 273, 300 Kelvin. When it expands to double its volume. So V1 is V means V2 is 2V double. At constant pressure, so pressure is constant, then work done. So at constant pressure means either P delta V or NR delta T. Now at constant pressure, V2 by V1 equal to T2 by T1 because V proportional to T. So that T2 also becomes 2T1. So T2 will become 600 Kelvin. Why? Because we don't know the pressure. Then work done will become NR delta T. N is given, R is known thing. R value is universal gas constant 8.314 joule per mole per Kelvin. So just substitute all the values. Next, work done on heating 1 mole of helium adiabatically through 3 degrees Celsius is W. When the work done on heating 3 moles of hydrogen adiabatically through the same change in temperature is work done in adiabatic process is NR delta T by 1 minus gamma. So same gas they are telling gamma is same and they are changing number of moles. R is constant. Delta T through same change in temperature. So work done is directly proportional to only N. Then W2 by W1 equal to N2 by N1. N2 is 3 moles, N1 is 1 moles and W2 equal to 3 times W1. That's it. Now 1 mole of oxygen is heated at constant pressure. So pressure is constant. At temperature 0 degrees Celsius means 0 plus 273 Kelvin of heat that should be given to double its volume. So V1 equal to V, V2 equal to 2V at same pressure. So again, they are talking about isobaric process, calorie per gram per Kelvin. Now here 1 mole of oxygen is heated at constant pressure from 0 degrees Celsius. The amount of heat that should be given to double its volume. So volume doubled means again pressure, temperature also doubled. T2, this is T1 means T2 will become 2T1. So that 2 into 273, first thing. Now they are asking the amount of heat. So delta Q equal to at constant pressure NCP delta T. Now N is 1 mole. CP they have given. Delta T we found it. But here CP you have to take care. It is in terms of calorie. Okay, answer is in terms of calorie only, so no problem. So directly you can substitute. So this is the way you need to check the proper conversion of units also, and you need to take proper units. Next, 1 gram mole of a perfect gas at 100 degrees Celsius expands isothermally until its volume is doubled. Isothermally means temperature constant. At what temperature? 100 degrees Celsius means 373 Kelvin. Until its volume is doubled means V1 V and V2 is 2V. Then the work done. Work done means 2.303 nRT log V2 by V1. Here all the values they have given. See 2.303 number of moles, 1 gram mole. And capital R is 2 calorie per mole, nothing but 8.314 joule per mole. And temperature is 373. Then log V2 by V1, 2V by V. Then just substitute it. Then you will get the value. So this is how you can solve. Log 2 is there. Log 2 value. That is also important. So log 2 base 10 is 0.3010. But usually in the examination, whenever such value is required to solve the question, they will mention in the question. Now, last and final question. So work done. Here cyclic process they are given. The work done means work done is equal to area of cycle. So what kind of cycle it is? It is triangle. See, this is V naught and this is 4 V naught. So this will become how much? This is nothing but 4 V naught minus V naught. And then similar way this is, see this total length is 3 P naught. This is P naught. So this will become 3 P naught minus P naught. So that area equal to half into base into height. Now here base is 3 V naught. Height is 2 P naught. So that work nothing but area equal to half into 3 V naught into 2 P naught equal to 3 P naught V naught, because 2 get cancelled. So this way they can ask the question based on whatever equations we have seen, maybe on any process. So please just try to understand what is heat, internal energy and work done, and what are the different process, and what is the formula for heat or internal energy or work done for particular process. Accordingly, you can calculate the numericals. So similar questions I have given as an assignment. So please just try to solve all the questions. Then you will get the better idea. So thank you all. We'll continue in the next session with the next class.